Okay, so right now we are going through lessons 2-2 and 2-3. We're talking about functions, non-functions, linear functions, and nonlinear functions. And so I'm going to go through the first page, front and back, of just information about the difference between a function and non-function, and linear and nonlinear. Okay, so let's read the definition of a function. It's a relationship that pairs each input value, input is x, with exactly one output value. Your output is y. Okay, so look at this equation right here. We have x equals 2x, or I'm sorry, y equals 2x plus 3. X is your input value. You're going to put in a number into the x, and out comes a value for y. So that's why it's called the input and the output. If an equation produces two outputs for one input, it is not a function. What does that mean? That means that if we put in an input here, an x value here, and we get an output of one number, but then we put in the same input and get a different output, something's wrong. What does that mean? Okay, so let's look at it this way. Okay, so say I wanted to input 1 for x to figure out what my output, my y is. Okay, so I know my ordered pair is 1 and I don't know what my y is yet. So let's plug 1 into the equation and get an output. When I plug 1 into where the x is, I get 2 times 1 is 2 and 2 plus 3 is 5. So my output is 5. So my y, my x is 1, my y is 5. That shows that I have a function. But what happens if I say, oh, I'm going to put 1 in the equation and now I'm going to get 4? No, you can't do that. Anytime you put 1 into this equation, you will always get 5. So the difference between a function and a non-function is, in a function, for every x value you get exactly one y value. You can't duplicate your x values and get different y values for them. That's just not going to work. Let me show you what I'm talking about. If I input 1 for x, I get 4. If I input 2 for x, I get 8. If I input 3 for x, I get 12, and so on. Okay, so this is a function because for every x value, you have all your different x values get exactly one y value. But let's look over here. And sometimes it's easier to look at what a non-function is to help you understand it. Notice here that I have an input of 1 and an output of 4. But then here it says I can have an input of 1 and an output of 5. Well, no, you can't. Just like up here, I couldn't have an input of 1 and get 5 and then an input of 1 and also get 4. It doesn't make sense. So anytime your x repeats with a different y value or a different output, it is a non-function. So this is a table. Let's look at our ordered pairs here. This represents a function because for every x value, you get exactly one y value. But over here, look, I have two x values of 4, but then they have different outputs. Two x values of 5 with different outputs. That's not a function. Okay. So that's tables and ordered pairs and equations. Let's look at graphs. Graphs can be a little bit different. So a graph, you want to ask, does it pass the vertical line test? And I always put my arm up and I put it against the graph to see if it touches two x values. Okay. So the best way that I can show how to do this is if I were to run a pen across my graph, and this pen is kind of thick. Let's use a paper. I'm going to use a yellow piece of paper. Okay. If I were to run this yellow piece of paper across this graph right here, oops, I'm sorry, you can't see it. Is this line going to touch my yellow paper on the X in more than two spots? So I'm going to, so far this line is only touching it right here. Now it's only touching it here. And as I go, you'll see that that line never touches my yellow paper in two different spots. Okay, so that means this is a function. Let's go to one that is not a function, and that will be a little bit easier to see. I'm going to use this one right here. So Here is my graph. And it's a little bit confusing because you see all these different lines, but really what is taking place here is this is the X, the Y and the X axis, okay? And then this line right here is showing you the vertical line test. So I'm going to use that line, but I'm going to put my yellow paper here. So see this line right here? It is this graph, this pink graph is touching my yellow paper here and here. That means it has a duplicated X because this right here is hitting the X axis. So let me just give you maybe an idea of what I'm doing. And I'm going to use ordered pairs to help. So say this is 1 and this is 2. So the X on the X axis, we're hitting 2. And then over here we have 1, 2, 3. It's hitting 3 and 1, 2, negative 3. So what I'm going to do is I'm going to take these 2 points that it's hitting and I'm going to write their ordered pairs on the graph. So the ordered pair for this one is 2, 3, and the ordered pair for this one is 2, negative 3. Do you see the problem based on what we did up here with our functions? And right here? The problem is that you have the same input getting different outputs. That represents a non-function. On a graph, though, you shouldn't have to do all of this work. You should be able to look at it and see, oh, that doesn't pass the vertical line test. My paper is touching the graph or the line that has been graphed twice on the vertical line. So let's look at another one. Let's look at this one over here. Over here, you have a graph line, and this is your y-axis, and this is your x-axis, and this line represents the vertical line that's testing to see, is it crossing that line twice on the x-axis? So let's look at it. I'm going to use the same paper, but the other side. So here's my line. Notice that this graph is touching my paper or my vertical line test twice, hitting the same point across the x-axis, but giving me 2 different points on the y-axis. And you can't have that. That did not pass the vertical line test. Therefore, it is not a function. Now, some people say, oh, well, look at this parabola right here. That's what that's called, a parabola. It's hitting it more than once, but it's not. Watch what happens when I pull. I'm doing a vertical line test. I'm going to pull this line slowly across, and it's never hitting my yellow paper more than once, which means that it is a function. Okay. So we have tables, we have ordered pairs, we have graphs. And with all of those, we should be able to tell whether or not an equation is represented by, or it's represented by a function or a non-function. Okay. Okay. So we're going to skip page 2. That's easily described as we're doing all of our examples. So let's look at some of the problems we have here. This actually is one big problem on one big page. So we're going to represent geometric relationships. We have rectangle 1, 2, 3, and 4, or image 1, 2, 3, and 4. And it says in the diagram above, what is the relationship between the number of rectangles and the perimeter of the figure they form? Use a table to represent the situation and then graph the results. So here we're going to use a table. And we're going to be able to look at it and see if it is a function or a non-function, okay? We're going to look at the number of rectangles. So in this image, we only have one rectangle, okay? So, excuse me, I'm going to clear this all off so I have space. So we have one rectangle, okay? And the perimeter. Now, when you go up here, the perimeter is 6 here on the side and 1. And to figure out the perimeter, you count all the edges up. So if I count the edges up, I have 1 plus 6 is 7, and I have 14. So my perimeter for the first image is 14. And then when I write that as an ordered pair, my X goes first, my Y goes second. So it'd be 1, 14. That's my ordered pair. Okay. Let's look at the second image. We have, and the number of rectangles is 2. Our perimeter, this time, we can't just add to this one. We have to actually figure it out. So we have 6 and 6 is 12, 13, 14, 15, 16. So it's 16. And then our ordered pair for this would be 2, 16. I want you to go ahead and finish the table, and then we'll come back and we'll do the graph together. Okay, so go ahead and check your table, make sure all of that information is right. And right now we are going to move over to the graph. Remember that when we did 2-1, I said that the big thing about graphs is you want increments on your X and Y axis, you want labels on your X and Y axis, and you want a title. So this should be fairly easy because the X axis represents the number of rectangles. So we're just going to write number of rectangles here. And then notice our number of rectangles just goes from 1 to 4. A lot of times what I'll do is I will skip a line. And if it's not going to use the entire side of the X axis, so I'm going to skip a line and put 1, skip a line, put 2, 3, 4. Okay. And then our Y axis is the perimeter, and we go all the way to 20. And so we'll need to figure out our increments for that, but let's label it perimeter. Now to label my increments, I always want to count how many I have and see if I can go by 1s or 2s. So let's see, 1, 2, 3, 4. It only goes up to 15, so I'm going to go by 2s, okay? So, oops. 2, 4. Okay. And then I'm going to give my graph a title, and I'm just going to give it a title of rectangles. If you want to make it a more interesting title, you can, as long as it's related to the situation that we're working with. Okay, now I'm going to plot my points that I just created. So I have 1, 14, 2, 16, 3, 18, and 4, 20. Okay. And then when and then I'm just going to leave it like that. Okay, so now I want to come up with an equation. So we have already learned that you can create your equation based on the graph, or you can create your equation based on the table. Now, if you notice here, we don't have a y-intercept, but if we were to go backwards with our slope, let's look at this. Our slope here is rising 2, and you might say, no, it's only going up 1 box. We'll look at our increments. Our increments are going up by 2. So really, when we go up 1 box, we're going up 2. And then it goes over 2 boxes. And you might say, well, it's running 2. But guess what? We skipped a line here. So really, it's going up 2 and over 1, making our slope 2. So our rise is 2, our run is 1. We have a slope of 2. So down here, I'm going to put M is 2. If I wanted to, using the graph, if I wanted to find my slope, I could just go backwards with my slope. So I'm going to go down 2 and over 1. And then that means that my y-intercept is 12. So B equals 12. Okay. So then I can put this into an equation, and it would be y equals 2x plus 12. All right, so the question then is, what if I didn't have a graph? How could I figure that out? And we've done this before, but I'm just going to remind you of what we did here. We used the slope formula and we took y2 minus y1, so 16 minus 14 over x2 minus x1, which is 2 minus 1. And that is how we get our slope. That's just a refresher because we've already done it. So 16 minus 14 is 2, 2 minus 1 is 1, and then we get 2. So we could get our slope that way, and then we can use our slope-intercept equation and by using the slope and a point to figure out our y-intercept. So what that looks like is you have y equals mx plus b. I'm going to choose my first ordered pair, 114. I'm going to plug the y in. My slope is 2. My x is 1. And I can figure out my b this way. So what would end up happening is you have 14 equals 2 plus b. You subtract 2 from each side, and you get 12. And that is our y-intercept. So I went quickly on that, but that's because we've already done that type of work on lesson 2-0, the pre-lesson before we got into the chapter. Okay, so let's look at this. I can draw my line now. I can just draw a line through my points. Does this table or graph represent a linear function? And we can say, yes, it does. It is linear. How do I know that it is linear? Well, 1, it forms a straight line. And 2, it has a constant rate of change, or constant rate of changes too, okay? So let's look for a pattern in the table, describe the pattern in words so you can write an equation to represent the relationship. Well, we've already written the equation, so now we're just gonna write what's going on with our image, our table, our graph, and our equation. And we're gonna apply it to the situation of the rectangle in the perimeter, okay? So what is happening each time that we add a rectangle to the image? And you will notice that every time we add a rectangle, the perimeter increases by 2. So that's what we're going to write. As you add, oops, can't see it. One rectangle to the stack, the perimeter increases by 2 units because we don't know the units. Wow, one big problem, but these are all representations of equations or of a problem. So you have a table that represents this image up here. You have a graph that represents the image in the table. You have an equation that represents the image of the table and the graph. And then you have words that represent it all. So there's so many different ways to represent a situation. It's just not by a graph or only by a table or only by equation. There's multiple ways. All right, so let's go to page 4. So this is another big problem. So what we're going to do is I'm going to start you off on it, and then I want you to try to work through some of this on your own just to see if you were able to grasp what we did in the other in the first example. Okay, so let's look at this. The table shows the relationship between the number of photos X you take and the amount of memory in megabytes left on your camera's memory chip. Is the relationship a linear function? So we're going to answer that at the very bottom, whether it's linear or nonlinear on number 6. So the first thing that I need you to do is analyze the table. What is going on? How is your X and your Y related? And I want you to describe what's happening in terms of X and Y, and then I want you to describe the real world situation. Okay, so that's what I want you to do first, and then we'll come back and we'll check to make sure we have those. So go ahead and try that on your own. Pause the video if you need to. Okay, so notice that when I analyzed my table, I noticed that the photos were going up by 1, but my memory was going down by 3 each time. And so when I described just the X and the Y, I described it as X increases by 1, Y is decreasing by 3. That's what's happening. X is increasing by 1, Y is decreasing by 3. In applying it to the real world situation, each time you take a photo, 3 megabytes of memory is being used. And you can word that in any way as long as you know, as long as you are recognizing that every photo takes away 3 megabytes of memory. All right, now what I'm going to have you do is I'm going to have you create your equation. So you're going to use the table, and you're going to use what you know about y-intercept. It's kind of given to you in the table, and I want you to create the equation. Okay, so take a minute to do that. Pause the video if you need to. Okay, so here is the equation, y equals negative 3x plus 512. Notice up here that your y-intercept is given to you. You didn't even have to do any work right here. Remember, when x is 0, your y-intercept is whatever the y value is, okay? And so that was given to you, so I know that 512 is this. And then I know that when I do my change in y up here, over change in x, I notice that each time my change in y is a negative 3 and my change in x is a positive 1, giving me a negative 3 for my rate of change or my slope. You could also use the slope formula, 509 minus 512 over 1 minus 0, and you end up with negative 3 over 1, which equals negative 3. So many ways to get the slope to create your equation. Okay, so now what I'm going to have you do is you're going to use the table in your equation, and you're going to create a graph that represents the situation. But one thing that I want you to look at is the increments on your y. Okay, I want to do the increments with you. So before I want you to do everything on your graph. I want you to label it. I want you to give it a title for the X and Y axis. I want you to do the increments on the X axis, but hold off on the Y. So I'm going to pause. I want you to complete the graph except for the increments on your Y axis, and then we'll come together and discuss that part. Okay, so I have my graph completed except for my increments, and it should look something like this. You may or may not have skipped a line, and either way is okay. It doesn't matter. But notice that our increments up here start at 512 and go down to 503. Now, normally I would say that your graph has to start at 0, but unfortunately our graph isn't that big, and our data is too close to each other to be able to go up by 25s, 50s, or 100s. So what we're going to do is we're going to create something called a break in the graph. And when you create a break in the graph, all that means is that you're not starting at 0, okay? And the graph might look off a little bit. So when you create that break, it looks something like this. You're going to start at the corner of this top box. You're going to go over, you're going to come back, and then you're going to go over a little bit and down. It looks like a little zigzag type of a thing. By creating that break, I am now going to start at 500. So 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I can do that. So I'm going to start here at 500. And then 501 all the way to 512. So go ahead and create your increments for this graph. Oops, I put 512 right there. It should be 502. So go ahead and finish off the increments on the graph. I want you to plot your points or your equation, and then we'll compare the graphs. Okay, so this is what your graph should look like somewhat. Now, the reason that we don't typically like to do breaks in the graph is because it doesn't make the graph look accurate. It looks like that we're going to get down to no more photos left in by the way that this graph looks, and that's just not accurate. It's just because we started at 500, but we need to go all the way down to 0, and you're going to and then your memory will slowly keep declining. Now, question number 5 says, how many megabytes would you have left on your camera after taking 25 photos? Well, if you look up at your table, you'll notice that the number of photos is represented by the X. And if you look at our equation, X is right here. So all you're doing is you're writing out your equation. You're going to plug the 25 in there to figure out, after taking so many photos, how much memory do we have left? So what that looks like, y equals negative 3x plus 512. X represents the number of photos. So we're going to take this 25 photos and we're going to plug it in here to solve. So y equals negative 3 times 25 plus 512. Okay, I want you to go ahead and solve that equation, answer it, and then I want you to answer number 6 as well, and then we'll come back and share. Okay, so after taking 25 photos, you will have 437 megabytes left, and this is a linear equation because there is a constant rate of change of a negative 3, and the graph forms a straight line. Okay. All right, let's go ahead and move on to page 5. On page 5, we have 4 different graphs. And this one, basically what you're going to be doing is you are going to be taking this situation, you're going to be creating graphs that represent the table and the situation. So let's look at the situation first. It says the area in square inches of a pizza is a function of its radius, R, in inches. The cost C in dollars of the sauce for a pizza is a function of the weight W in ounces, or sauce used. Refer to the tables below. So we have 2 different situations, or 2 different comparisons, but the same situation. So what I want you to notice on here is that this is saying that the area in square inches of a pizza is a function of the radius. So when it says that the area is a function of the radius, that is telling us that the area is dependent on the radius. So the area depends on what the radius of the pizza is. So the area, since it is dependent on, it is the dependent variable. This would represent our y, and then the radius would represent our independent variable, the x. Let's look at the cost, sauce cost. Okay, so the cost C is a function of the weight W. What does that mean? That's saying cost is dependent on weight. Since cost is dependent on, it is our dependent variable, or y, making weight our independent variable. And the reason that I'm going over this is because you're going to be given some problems in the homework where it tells you something is something is a function of something, and you have to be able to determine which one is the independent variable, which one's the dependent variable, so you know where to place it in your table or on your graph or in your equation. Okay, so what I'm going to have you do is I'm going to have you set up both of these graphs, figure out your own increments, and then we're going to come back together and just kind of look at them and discuss them a little bit. Okay, so go ahead and do that. Okay, so when you're done with your graphs, this is what they should look like. Now, if your increments were different, it might look a little bit different, but the point is that the first graph about the pizza area, you should have a nonlinear graph, and then the second graph should be linear. And so I want you to make sure you get these on your graphs so you could see the difference. Okay. We are going to skip this interpreting graphs. It'll be a warm up in class that we'll do, and we're going to go ahead and move to the back. Page 6. Okay, so we are creating equations from ordered pairs. Okay, and on this, we're going to fill out our table based on the ordered pair. We're going to graph our results, and then we're going to come up with an equation. So I'm going to do the first one with you, and then you're going to do the next one on your own. You may already have an idea of how to do this. You can go ahead and go with it and then check your answers at the end. So I'm going to plug these ordered pairs into my table, 1, 5. 1 represents the X, 5 represents the Y. And the same for all of these. So we have 1, 5, 2, 8, 3, 11, 4, 14, and 5, 17. Okay. Now what I'm going to do is I'm going to put increments on my graph. Now notice this is not a real world situation, so I don't have a title or labels or anything, just increments. So my x-axis goes to 5, so I'm going to start at 0 and skip a line. 1, 2, 3, 4, 5. And then my y-axis goes to 17. I'm just going to go by ones on that one. Oh, if I can. Uh-oh, it only goes to 15. I'm going to extend it. 15, 16. I'm just going to estimate. Okay. Now I'm going to plot my points. So I have 1, 5, 2, 8, 3, 11, 4, 14, and then 5 is going to go up here to 17. Okay, and I'm going to draw my line. Okay. And now I'm going to come up with equation. Remember, there's 2 ways to get your equations, from the table or from the graph. I find it easy to get it from the graph. The only problem is that I don't know what my y-intercept is, if that is accurate enough. So I am going to go ahead and use the table. So I start with y equals mx plus b. Now what I can do is I can use my graph to get the slope if I wanted to. So I know that I'm rising 1, 2, 3. That's my rise. And I'm running, it looks like 2, but remember I skipped a line, so it's only 1. So my slope is up 3 over 1, which is 3. Now, if I wanted to check that with my table, I could do that. So I'm going up 3 and up 1. And you want to make sure that that is the same every time, and it is. I could also do my y2 minus y1 over x2 minus x1, and you get 3 over 1, which is 3. So we know the slope is 3. Now what I'm going to do is I'm going to choose an x value and a y value, and I already know my slope is 3. So my x value is going to be 1, my y value is going to be 5. Now I'm going to use my equation. Y equals mx plus b. And I'm going to plug in my slope, my x and my y. So my y is 5, my slope is 3, my x is 1. So I get 2 is my b. And you'll notice that I'm very close to the 2 on my table. So when I write out my equation, I get y equals my slope, which is 3, plus my y-intercept, which is 2. So that's the equation for this graph. Okay. All right, what I want you to do is I want you to go ahead and try to do this last example on your own. And then, so you're going to pause the video and then you're going to come back and you're going to check with me. Okay. Okay, so this graph was a little bit interesting. There were negatives and I only put a one quadrant graph. So what I ended up doing is just creating 4 quadrants. And then my increments were all by 2 since I had to go all the way up to 28. So sometimes you have to improvise a little bit on your graphs. And so that's what I did. One thing that I really want you to make sure though is that your equation is correct. That's the big thing here. Okay. So that concludes lessons 2-2 and 2-3. And you can check Canvas for your homework.